Welcome to Biology My Passion. I am Soumya Harikrishna. We are learning the chapter Force and Laws of Motion. We learned first two laws of motion by Newton. The first law taught us how the motion of an object is influenced by force. Through the second law, we learned how to measure or determine the force. Now let's discuss the third law of motion. The third law of motion states that when an object exerts a force on another object, the second object instantaneously exerts a force back on the first. In very simple terms, for every action, there is an equal and opposite reaction. Now we have to remember these two forces are always equal in magnitude but opposite in direction. Suppose if I am hitting my other hand with this, I am applying a force on this. But this hand will instantaneously, that means immediately exert an equal force on the first hand. So they are equal in magnitude but they are opposite in direction. One thing to remember here is these forces act on different objects and never on the same object. For example, first time I was applying from my left hand to right, then the right hand is applying back on the left hand. So these are two opposite forces though their magnitude is equal and it's not on the same object. First force is on the right hand, second is on the left hand. For example, during football, the players are so fast in their movement and they are so focused and going behind the ball, sometimes they hit each other. We have seen in many matches that the players are getting hurt on the field. And why this is happening? Because the one who is hitting also get hurt, the one who is being hit also get the hurt. Why? Because suppose in this you can see player 1 is wearing that yellow shirt. Suppose this is player A and this is player B. So A is acting a force on B, hitting, and B will immediately give back a force or exert a force back in equal magnitude but opposite direction, because the directions you can see it is opposite. So we can say what A applied on B is called the action force, whereas B applied on A is reaction force. In this picture, you can see two spring balances. The left one is B and the right on my screen is A. So B is connected to a rigid support like a wall, it is attached, and the end of A is free where we are pulling. Imagine when you are pulling spring balance A and see the reading, you can see the same reading is shown on both the balances. How is that possible? When we are pulling A will be applying a force on B. At the same time, can B sit idle? No. B will apply an equal but opposite force on A. So in this case, which is action, which is reaction? Balance A applying on B is called a action. Here A is there. A is showing an action to B. So this is action. But B will be giving an equal and opposite force, that is exerting an equal and opposite force, that is called a reaction. So here, where is action happening? Action is happening on B. Where is reaction is happening? Reaction is happening on A. So this is what we understood. These two forces are equal in magnitude, opposite in direction, but they are acting on two different objects. This is a very important concept. You have to clearly understand this. Okay, they are acting on two different objects, not on the same object. So from this we can say that for every action there is an equal and opposite reaction. Imagine this situation when you are walking on the road. How are we able to walk? You know that the muscles in our legs are actually helping it, but simply with the use of muscles can we move? No. Once you are standing or you are at rest and you have to start moving, that means you have to accelerate. You know that according to the laws we learned, second law of motion, we learned that we need some kind of force there. We need to exert some force. Where are we exerting the force? We are exerting the force on the ground. Okay, so when we are walking, we are applying a force on the ground that can be called as action. We are in action. The force acted on the ground is called action. Now what will ground do? Ground will exert an equal and opposite force, that is to the body. So that is called a reaction. So because of this we are able to move. Okay, so when we are walking, we are applying a force called action on the ground. As a result, the ground will apply an equal and opposite force on us, that is called a reaction. So because of this we are able to walk forward. Now when we are walking, we saw that We are applying a force on the ground. As a result, the ground is applying an equal and opposite force, and we are able to accelerate. But is the ground accelerating? No. The movement or the acceleration on the two bodies can be different. Why? Because the body or the objects on which the force exerted is not the same. So the acceleration also can vary. This can be easily explained by using the example of shooting using a gun. When we are firing from a gun, what happens? The gun will be applying a force, that is action, on the bullet. As a result, the bullet will go with a high velocity. But at the same time, there is a reaction force. The bullet also applies an equal and opposite force on the gun. But is the gun getting moved with the same velocity? No, because the gun is very heavy. So it cannot have the same effect, but still the gun will move back a bit. That is called a recoiling of gun. So the bullet will be fired with a very high velocity because of the force exerted or the action exerted on it, whereas it will apply a reaction force, but it has a different acceleration on the gun because gun is heavier than the bullet, but still it is called a recoiling of the gun. Now look at this case. A sailor is jumping out of the boat. So in this case, what is happening? He is applying a force on the boat. That is called an action force. Because of the action force, the boat is moving backwards. But at the same time, the boat is applying a reaction force. Because of that, he is pushed forward. So this is how the movement is happening here. Imagine there are two balls, A and B, and mass of A is MA and mass of B is MB. They are traveling in a straight line along the same direction, and this is moving with a velocity of UA and this is moving with a velocity of UB, and UA is greater than UB. So eventually what happens, this UA will come and hit a UB, right? That means the ball A will come and hit a B. So at that time, the collision lasts for a small time t. So the force applied by A to B can be considered as force AB. Then we know that B will apply an equal and opposite force, that is called a FBA. After collision, the velocity of ball A is VA and that of ball B is VB. So before collision, the momentum we can take as MUA for the first ball A, and after collision it becomes MVA, right? So change in momentum, what is change in momentum here? We can take it as M into VA minus UA, right, upon T. That is for the first ball. The same way second will be MB, that is rate of change of momentum I am telling, because initial velocity momentum will be M into UB. So, final will be M into VB. So M is a common factor. If we take out, we can take final velocity minus initial velocity upon time is the rate of change of momentum. So this is for ball A, this is for ball B. If you apply this, we know that MA upon T, MA into VA minus UA upon T is equal to minus MB by VB minus UB upon T. Now let's solve this. If you simplify this, we will finally get MA V, this is VA minus UA, right? So MA VA minus MA UA is equal to minus MB VB plus MB UB, because minus and minus we get plus. Now we transpose this. We are bringing U to one side and V to other side. So we can see that MA UA plus MB UB is equal to MA VA plus MB VB. That is, here we talked about a before collision, that is total momentum before collision. Here we are talking about the total momentum after collision. This is the final momentum. The total momentum remains the same in both the cases. In this ideal situation, we can say that the total momentum before collision is remained the same as the total momentum after collision. So this can be considered as law of conservation of momentum. Or in other words, we can say that the total momentum remains unchanged even after the collision. But here no external unbalanced force is acting on these objects. So these are the main concepts that we discuss in this chapter. Actually, the chapter is very simple. You just have to understand the three laws of motion. First one was describing the inertia. Second one was describing the momentum. Third is the actually giving us an idea about the total conservation of momentum also, action and reaction. Another video I'll be bringing with the numericals related to this chapter and questions. So till then, keep watching my channel. If you understand what I teach, please give a like and also share with your friends. And if you have any suggestions or questions, you ask in the comment box. Not subscribed and watching, please do subscribe to my channel. Thank you for watching Biology My Passion.